Okay, now we're going to solve equations that are a little more complicated. Now you'll notice the directions here are a little different. It says solve each equation on the interval from 0 to 2 pi. So we're not asking for all solutions here. We're not going to put the plus 2 pi k or the plus 360k. This is saying we're only going to go, so only angles kind of one time around the circle. And the 0 and the 2 pi tells us we want our answer in radians. If it said 0 to 360 degrees, then we would do it in degrees. Okay, now the first one we're going to look at here, it says sine of 4x is equal to negative square root of 2 over 2. Now before we get too into this, let's see what that looks like. I've put in sine of 4x, negative square root of 2 over 2. In my window, I've changed from 0 and I've put in 2 pi. Okay, and you'll notice, so here's our graph. This is the x-axis right along here. So here's our sine, and the 4 pi has horizontally shrunk it by a factor of 4. Okay, so where normally we'd only get 1 period in here, we've actually gotten 4 periods in between 0 and 2 pi. And this line down here is our negative square root of 2 over 2. So one thing we can do just to see how many answers we should get is count how many times it intersects. So 1, 2, 3, 4, 5, 6, 7, 8. So we should have 8 solutions. So now let's talk about how we'll go about finding that. Now our equation, or our directions, tell us we want our answers to be between 0 and 2 pi. So x is what we're trying to solve for. We want x to be between 0 and 2 pi. Now, here's what's a little tricky, is we're not actually going to be, when we use the unit circle, looking at x, we're going to be looking at 4x. So we're going to multiply everything through by 4 here. And 4 times 0 is 0. 4x is less than 8 pi. Okay, so we're actually, when we first solve this, 8 pi would be 4 times around the circle. So first we're going to have to come up with a list of angles. If we go 4 times around the circle, where the sine is equal to negative square root of 2 over 2. Now I know you're probably saying, wait, you just said we're only going to go 1 time around the circle. Well, our final answer, all of them will be only 1 time around the circle. But to get all 8 of these solutions, we're going to have to look a little further. So bear with me for a minute. We're going to use our unit circle. Okay, let's see if I can. Okay, and we're going to look on here. Where is sine negative square root of 2 over 2? So first we're just going to write down the places 1 time around. So negative square root of 2 over 2, that's going to be in the 3rd and the 4th quadrant. We want the y coordinates. So that's going to be at 5 pi over 4 and 7 pi over 4. So we're going to write those down. 5 pi over 4 and 7 pi over 4. Now the only time where we'll get sine equal to negative square root of 2 over 2 is at one of these angles. So we need to go 4 times around, meaning we need to add 2 pi to these angles 4 times. Or 3 more times, because this was our first time, to get a total of 4 times around the circle. Now 2 pi, we want it in terms of fourths. If we multiply by 4 over 4, we get 8 pi over 4. So 2 pi is equal to 8 pi over 4. So since this is in fourths, we're going to add 8 pi over 4 to each of these. And so really we're just adding 8 in the numerator. So 5 pi over 4 plus 8 pi over 4 would be 13 pi over 4. Then we're going to add 8 pi over 4 again. So that will be 21 pi over 4. And to get our 4th time around the circle, we would have 29 pi over 4. Now we're also going to do it down here. So we'd have 15 pi over 4, 23 pi over 4, and 31 pi over 4. So for all of these, I've added, you know, to go from here to here, I've added 8 pi over 4, go from here to here, okay, and so on for all of those. Now, what we're saying is that 4x is actually equal to each of these. So now we have one more step here. What we're really saying is that 4x is equal to 5 pi over 4. 4x is equal to 13 pi over 4. 4x equals 21 pi over 4. 4x equals 29 pi over 4. And then we have the other 4 of them. So 4x equals 7 pi over 4. 4x equals 15 pi over 4. 4x equals 23 pi over 4. And 4x equals 31 pi over 4. Now, to get just x in all of these, we need to divide both sides by 4. Now, when we're dividing the fraction by 4, we're really multiplying it by 1/4. So what we're going to do here, you know, so dividing by 4, we're saying we're multiplying by 1/4, which would give us 5 pi over 16. All of these denominators are going to become 16. So here we're going to get x equals 5 pi over 16. X equals 13 pi over 16. X equals 21 pi over 16. X equals 29 pi over 16. X equals 7 pi over 16. X equals 15 pi over 16. X equals 23 pi over 16. And x equals 31 pi over 16. Now, if we want to write out all of our solutions, so our solution set, we could put them in curly brackets here. We're going to list these in order. So 5 pi over 16. Then we'd come out down here to our 7 pi over 16. 13 pi over 16. 15 pi over 16. 21 pi over 16. 23 pi over 16. 29 pi over 16. And 31 pi over 16. And we see that we did get 8 of them, just like we thought we would from the graph. Okay, let's look at this one. So this one says we want to know where is cosine of 2 theta over 3 equal to -1. And here I know there's a theta instead of an x, but it's still our variable. We're just solving for theta. So we're saying we want to find theta between 0 and 2 pi, where this equation would be true. So the first thing we're going to do is if we want theta to be between 0 and 2 pi, well, we're going to be solving for 2 theta over 3. So we're going to multiply by, we're going to multiply everything through by 2/3. So 2/3 times 0 would give us 0 is less than 2/3 theta is less than 4 pi over 3. Now 4 pi over 3, that's not even a full time around the circle. Here, we're only going to be looking for angles between 0 and 4 pi over 3, where cosine is equal to -1. So let me say that again with this up. Between 0 and 4 pi over 3, so we're going to stop here, where cosine, the x value, is equal to -1. And that only happens in one place. It only happens here at pi. So the only angle we have here is pi, so we're going to say 2 over 3 theta equals pi. Now to solve for theta, we'll multiply both sides by 3/2. So we'll get theta equals 3 pi over 2, and that's our solution. Now, just to kind of show you why this works, let's do a check. Remember how we check to see if something's a solution to the equation? We're going to plug it in and see if the equation holds true. So we're going to say, okay, if we have cosine of 2 theta, we'll plug in 3 pi over 2 over 3, is that equal to -1? Okay, well, if we look at the numerator here, these 2's would cancel out, so we'd have 3 pi over 3. So we'd say, is cosine of pi equal to -1? Well, if we pull up our unit circle, cosine of pi is -1. So that checks out. Now, unfortunately, that doesn't guarantee that we have all of them, but we can at least say that we know the solution we have is a valid solution. Okay, we've got one more that we need to put together here. Gonna add another piece to this. So here we have sine of 2x minus pi over 4. We want to know, where is that equal to square root of 2 over 2? Well, think about our transformations for a minute. The 2x in here is going to horizontally shrink it by a factor of 2, and the minus pi over 4 is going to shift it to the left by pi over 4. So let's first get a handle on how many solutions we're going to have. So let's plug this in. So we want sine of 2x minus pi over 4 and we want to know, where is that equal to square root of 2 over 2, so I'll get rid of the negative. And we still want this between 0 and 2 pi. So there's our sine of 2x minus pi over 4. And there's our square root of 2 over 2. So if we count the number of intersections, we see we're going to get 4 solutions. So we can at least write that down to know how many we're looking for. Okay, now to kind of see where we're going to get our first set of answers, we need to say, okay, well, we want our final answer x to be between 0 and 2 pi. Well, now to know where we're going to first look, we need to transform this to look like 2x minus pi over 4. So the first thing I'm going to do is multiply everything by 2. So we'll say, okay, 0 has to be less than 4, or sorry, just that should be 2x. Getting ahead of myself. 2x is less than 4 pi. Okay, now we're going to subtract pi over 4 all the way across. So we're going to say, okay, we need to look from negative pi over 4 to, now 4 pi would be 16 pi over 4, so minus pi over 4 would be 15 pi over 4. So this is where we're going to look, between negative pi over 4 and 15 pi over 4. So this is going negative once, and this is going just by 45 degrees, and this is almost going 4 times around the circle. So really what we're saying is we're starting here, which would be negative pi over 4, and going around 4 times. Now, notice the only place where sine is square root of 2 over 2 is at pi over 4 and 3 pi over 4. So that's going to be our starting point. And we know, since we have our denominators are 4 here, we need to add 8 pi over 4 each time to add 2 pi to go 1 time around the circle. So we'd have 9 pi over 4. Now look what happens if we try to add that again. We would get to 17 pi over 4. Now that's too big. The biggest we want to get is 15 pi over 4. So we're going to cross that off. Okay, so if we add, sorry, before I said this was 4 times around the circle, this would be 2 times around the circle, because it's almost 8 pi. No, sorry, it's almost 4 pi. If we had 16 pi over 4, that would be 4 pi, which would be 2 times around the circle. So here if we add 8 pi over 4, we would have 11 pi over 4. And if we added it again, we'd get 19 pi over 4, which is too big. So the 4 we're starting with are pi over 4, 9 pi over 4, 3 pi over 4, and 11 pi over 4. And here's where we need to set up 4 equations. Okay, so we're going to set up the equation 2x minus pi over 4 equals pi over 4. 2x minus pi over 4 equals 9 pi over 4. 2x minus pi over 4 equals 3 pi over 4. And 2x minus pi over 4 equals 11 pi over 4. So to solve each of these, we'll add pi over 4 to both sides. That would give us 2x equals 2 pi over 4. We need to divide both sides by 2. If we do that, we're going to have x. We can just divide the top by 2. We'd have x equals pi over 4. So that's one solution. Here, when we add pi over 4 to both sides, we'd have 2x equals 10 pi over 4. And we divide both sides by 2, we'd get x equals 5 pi over 4. Here, when we add pi over 4, we'd have 4 pi over 4. Divide both sides by 2, we'd have 2 pi over 4. Right, which is the same as pi over 2. Here, when we add pi over 4, we'd have 12 pi over 4. When we divide by 2, we're going to have 6 pi over 4, which reduces to 3 pi over 2. Okay, so here we want to, our solutions. We've got pi over 4. Sorry, I don't know why. Jumped ahead again. So pi over 4. And then we've got pi over 2. And then 5 pi over 4. And 3 pi over 2. Okay, and those are our solutions.